That's recorded.
Okay, good.
Thank you. Okay, then today we're gonna do area of circle. We talked about, yeah. I guess it's just when I do my hair like this.
Wow. I noticed.
That is all of the notes, so we will do examples when everyone is. Okay, so the area of a circle, we talked yesterday, the formal definition of the area of a circle is the limit as the, inscribed polygons, the limit of the areas of the inscribed regular polygons, so the more sides of a regular polygon that we have that would be inscribed in a circle, it would be approaching the area of the circle. And so the area is pi r squared. That also can be derived from the circumference formula, and your book talks about that if you are interested. And then we will also be finding the area of sectors of a circle, so that would just be like, if you had a pie, how much would one piece of the pie be? So, to do that, we just need to know the degrees, the degree of the arc or the degree of the central angle, which would be the same thing. And if we divide that by the total number of degrees in a circle and multiply that by the regular area, that would give us the area of one sector, which would make sense. So we have the fraction of the whole area. Okay, so we'll do like we did yesterday and go through a couple examples from your book. So if you want to be looking there on page 327. Okay. Let's do number 4. Find the area of a circle in which the diameter equals 6 times the square root of 3. So with circumference, there's two formulas basically that we use. We could use either 2 pi r or we could use the pi times the diameter, because 2 pi would equal the diameter. With area, there's not an easier way to do that, so we're just going to, if we're given the diameter, we're going to divide it by 2 in order to find the radius to use in the formula. So if the diameter is 6 root 3, what is the radius? Morgan?
3 root 3.
3 root 3. So the area is going to be pi times the radius squared. And so what would 3 root 3 squared be, Morgan?
27.
Good, 27. So the area here would be 27 pi. Now for those of you who need a little extra with the square roots, I know that there's a couple of you. That would mean 3 squared and the square root of 3 squared. 3 squared would give you 9. The square root of 3 squared, the square root and the square root would undo each other, so that would just give you 3. So we'd have 9 times 3, and that's how we would get the 27. Okay? Alright, let's do number 8. Find the radius of a circle in which the area equals 48 pi. So if the area equals 48 pi, that will equal pi times the radius squared. So to solve that for the radius,
You have to take the square root of 48.
right, okay, I'm gonna show this step. That might be obvious to some of you. If we divide by pi, the pi's will be gone, and we'd have 48 equals the radius squared. And so yes, then we need to take the square root of 48, which will not be a nice number, but what would that be in simplest radical form?
7.
Hmm?
7.
If you rounded it, it would be nearly 7, yes. But what would it be exactly in simplest radical form? Sorry?
4 root 3.
4 root 3? Okay, because 48 would be 6 times 8. So we could take out 2 2s, or 4, and then 3 would be left in the radical. the radius would be 4 root 3. Questions? Okay. Number 12. What is the ratio of the radii of two circles whose areas are in the ratio 1 to 2? So with circumference, we said that if the circumferences are proportional or have the same ratio, then the radii of the same two circles would have the same ratio. Well, that's not the case with area. Okay, so if the areas are in the ratio of 1 to 2, let's just say the area of one circle is 1, or let's just say 1 pi and 2 pi. Then their radiuses, pi r radius of the first one squared, pi r radius of the second squared. So if we get rid of all the pi's, divide out all the pi's, we'd have 1/2 would equal the first radius squared divided by the second radius squared. And so, and this is just sort of to illustrate why this is the case. You wouldn't have to work it out like this every time. But what is going to be the relationship between the radiuses? Or how would we find the radii, the ratio of the radii? Right now they're both being squared, right? So if I just wanted the ratio of the radii, what would I have to do? Morgan?
Square root both
Square
sides.
root it, yeah. So, if you're given the ratio of the areas of a circle, the ratio of the radii would be the square root of the areas. So, radius 1 over radius 2. The ratio is going to be the square root of 1, which is 1, and then the square root of 2, which cannot be any simpler. So the ratio of the radii would be 1 to the square root of 2. Basically, you're going to take the square root of each. But that would be why you would do that. Does anyone have any clarifying questions on that? Morgan?
Like, that makes sense, but I don't understand. Like, I would know how to do it, but I don't understand why you would do it. Does that make sense?
Like, why do you want to know that, or?
Like, I don't understand how that makes sense. How, like, you have the area is 1 to 2, and then the ratio is 1 to square root. I don't get that.
Of the radii. Because, okay, so if one circle is twice as big, basically that's what this is saying. One circle is twice as big as another circle. So what is the relationship of their radii? Well, because to get the area of the circle, if one's twice as big as the other one, you are going to have to take the radius and square it to make the area twice as big. The radius is only going to actually be the square, the bigger one would only be the square root of the other radius. Because you have to square the radius to get the circle. So for example, if you have a circle with a radius of, that's bad. These numbers aren't very nice to work with. If this circle has an area of 8, and this circle has an area of 4 pi. That would be the ratio of 1 to 2, right? Well, the radius of this circle, I would take the square root of it to find the radius of this circle. is what that's saying.
Oh, cause the square root is opposite of squaring it, so if you were going from the radius to the area, you would square it. So if you're going from the area to the radius, you just take the square root, cause these
Yes.
are opposites? Okay, that's simple.
Okay.
Okay, so
Good.
does it always work to do that? So like for number 10, would it just be 9 and the square root of 16?
It would be the square root of 9 and the square root of 16, so it would be 3 to 4. You have to take the square root of both. I took the square root of 1 and got 1, that's why.
Oh, okay, that makes sense. Okay. So number 9 would just be 2 and 9?
Mm-hmm.
Okay, thank you.
Okay, is everybody good? Alright.
The only thing is, can you have square root 2 on the bottom?
That's what I was
Well,
wondering.
since we're gonna write it like this, how they did it with the colon in between, we're not gonna write it as a fraction. You can leave it like that. It's a ratio and not a fraction, which fractions are ratios, but you know what I'm saying, I think. Okay, and let's do number 15. Okay, find the area of a sector with a 60-degree arc and radius of 3 square root 2. Okay, so basically we find the area of a circle that would have this radius, or you can use the formula that's above. But, so that would be pi times 3 root 2 squared. 3 root 2 squared, that means 3 squared and root 2 squared. So that would give you 9 times 2, which would be 18. So the area of the circle with that radius would be 18 pi. And if we're finding the area of a sector of that circle with a 60-degree arc, we take 60 degrees divided by 360 degrees and multiply that by the area. Or in other words, 1/6. I'm having a hard time writing today. So that would be 3 pi. Okay,
I'm confused on why you have to find the area of the whole circle first. It's like the area we're going on, but the
formula.
yeah, is like pi radius.
Yes, which is, this is the formula for the radius, or for the area of a circle, the pi r squared. So I just did that part first and then multiplied it by this part.
Okay.
But you can just put it all straight into the formula.
Okay.
Okay? Other questions? Alright, then your assignment is page 327, 1 through 14. Obviously, you can skip 4, 8, and 12 because we've already done those. Or you can write it down again if you want. And this will be the last new information before your final. So your final will be on basically all the area, perimeters, / circumference of polygons and circles.
Like, I don't really expect definitions, but all of a sudden. Same thing.